Uh, no, I guess there's some problem over here. This, yeah. So let's go to the first, like, uh, okay, yeah. So the first one is the x and y intercept. Okay, and then yeah. So the if you have a graph, the the x value that intersects with the x-axis is called the x-intercept, while the y value, I mean the y coordinate when the function intersects with the y-axis is the y-intercept. Uh, yeah. So the x-intercept is the first, yeah, and the y-intercept is when x equals to 0 and then y equals to some number. Uh, yeah, and the intercept is you need to have a function over there so that you will see when will the function pass through the x-axis, when will it pass through the y-axis. Okay, yeah, and the next one is so to find the axis of symmetry, we have this formula: x equals to uh negative b over 2a. And actually, the proof is from the completing the square. So how do we find this negative b over 2a? We actually perform a com- completing the square CTS. Okay, so completing the square is, so I will demonstrate how we uh, do this completing the square. So let's say we have ax squared plus bx plus c. Okay, so and then we first factor out a. Okay, and then what do we mean by completing the square is we need to complete the square, like if we have this x plus 2x, x squared plus 2x. So to complete the square, we add the 1 over there. We add the 1 and then we add the minus 1. So we have this one is a perfect square, x plus 1 squared minus 1. So to complete the square, we need to like match it with the x squared minus the what say the formula x squared plus minus 2ax plus a squared. Yeah, so this formula, and then so from here to add a term so that it is a perfect square, we need to add the term, uh let's see, b over, yeah, so we need to add the term b over 2a squared. So when we multiply them, I mean, so we have this middle term is 2 times x times b over 2a, because we need the formula a squared plus, I mean, here we are using the formula a squared plus 2ab plus b squared. So we need to complete the square by making the middle term, okay, this one, the middle term, to be equal to in the form 2 times a times b. Okay, so we need 2 times a, which is x, and b, which is b over 2a. And then so we cancel the 2, so we get b over 2a. Okay, and then I guess here is, Yeah, but yeah, I will be quick here. So x, yeah, but I'm like proving how do we get this b over 2a thing. Okay, yeah, so if we get this one from here to here, from this here to here, so we will get this x plus b over 2a square plus the c, but we need to take away the thing that we added back. Okay, so we need to take away this term that we added. So we need to minus the b square over 4a. Yeah. So this becomes the what's it the vertex form. Yeah. So we note that this one. So if we have completed the square, we know that to achieve the minimum point or the maximum point depends on a. We need to plug in x equals to negative b over 2a, because this whole term will become 0. So it will be like minimize or maximize the function which depends on the value of a. So when a is negative, okay, when a is negative, the function will be like upside down, okay, and then the vertex will have x coordinate to be negative b over 2a. While for the a positive part is just the same, but we have the x coordinate, the negative b over 2a to be the coordinate of the minimum point. Yeah, or the vertex. Okay, yeah, so this is how we get this negative b over 2a, which is by completing the squares. Okay, and then yeah, the next slide. So we find the axis of symmetry, and then so negative b over 2a, we get negative 1, and then we get the vertex negative 1. Oh, here uh is if we have negative 1 squared, it's actually equals to negative 1 times itself negative 1, so negative negative we get positive 1. Or oh no, because it has a bracket, so it's different. The negative sign is multiplied 2 times. Okay, yeah, and so the y, this one plus 1 minus 2 is 0. So the y is 0. So it's 0, and then so the vertex is 1, minus 1, and 0. Uh, yeah, the axis of symmetry is minus 1. Yeah. I mean, the axis of symmetry should be x equals to, because the axis, the axis of symmetry, because if you say negative 1, we will not know that is it the y equals to negative 1 or the, but I guess if the textbook teaches this one, I guess it's okay, but I will prefer to write the axis of symmetry to be x equals to negative 1. So this one is the x equals to, x equals to positive 1. So like this one is a axis, but if you write only 1 or negative 1, it will be a bit like confused about is it x equals to 1 or y equals to 1. But okay, so the next one, okay, negative b over 2a. So this one is my a, b, this one is a, this one is b. So negative b over 2a, we get negative 12. And we plug it back, negative 12 squared. You get 33, 1, 4, 3, 36, 39, 33, wait, 36, 39 minus 72, you get negative 36. Negative 33. Yeah, it's negative 33. And the axis is negative 12. Yeah. Okay, and then the next one is the same. We apply the negative 8 over 2 times 4, get 1. And then we plug in to find the vertex is 111, and the axis is 1. Okay. And the next one, uh, okay, 1, and then plug in, we get negative of 23, 21, negative 20, 33. So the vertex 1, 3, and then the axis is 1. Okay, here. So the domain and the range of a function, the domain is the x, the possible value of the x axis, while the y is the range, which is how much will the function get to. So how much will the function maps to? So the 2 to the x is the exponential function, like this one. So it has domain R and the range larger than or equal. So the range is not equal to 0 because uh, it is always positive, right? You will not get 0. Okay, yeah. And the same goes to 3 to the power x. It will not go to 0. Okay, because 0 is actually the what is that? Yeah, so it's like you will never get to 0, but you're going closer and closer to 0. Yeah, and then the third one is 44x. It's like this one. So is it the range also larger than or equal to 0? Because the range is like all the values here. So is it larger than or equal to 0? Eh? Oh, one third times. Oh, you need to flip the one third to the numerator, right? So if you have 1/1/3 is the same as 3, right? Yeah, so you can like cross factor the 2 first, and then you have 6 for as a result. Yeah, 6. -6. Yeah, 13. Yes, correct. Check. I guess 0 is 1, and then 3 is -3 is. Eh? Yeah, 0 is 1, and -3 is also easier. Yeah, because 0, you just get 1. Yeah, negative neg- -3 plus 12. Uh, you, I guess it's like 10. Yeah, it's like 10 negative 3 squared over 3 minus. So this one you get -3, so you get 10. Yeah, yes, it's 10. Yeah, it's upside. Yes, yeah, yeah, it's wider. Okay, so the domain is R, the range is less than or equal to the maximum. Uh, okay, so this one correct. Domain is R, and then so the domain is this one, and then the range is this one. So domain is R, and the range is less than or equal to the maximum. Okay. Yeah, so I guess we can extend to like 10:30, but depends on you. If you are like tired, then we can end at 10. Yes, okay. So now is on the question 12. Mm, but if it is upside down, then A should be, yeah. Yes. Yeah, it's quite hard this one. Uh, this is okay. So, C C is positive. Okay. So the first, uh, actually I forgot the answer, but now we'll go through the answer. Yeah. So A. So first A is actually larger, less than zero, not negative one because yeah because on A can only be like larger or or smaller. It cannot be equal to zero because if A is equal to zero, then this is not a quadratic form already. Yeah, yes. So only A can be larger or smaller than zero. So if it is upside down, then A is smaller than zero, right? If A is positive, then it is like a smile face, okay? And then when A is like negative, then it is a sad face. Yeah, so you can remember it like that, right? A positive and a negative, like yeah. And then the C actually we can see from the graph. So uh, so I can ask you like, what is the value of y when x is equal to zero? So when x equals to zero, what is y? Yeah, and then from the graph you can see that this one is c, right? So if it is at the upper side of the y-axis, should it be negative? Yeah, so c is also positive. I mean c is positive. So that crosses out the first two one. While b b is actually we can find b by the, the vertex formula. We have the b. Yeah, and if you see from this graph, the vertex x coordinate is positive, right? Because it's on the left, I mean on the right of y axis, right? So this one, the x coordinate is positive. I mean, is positive. Uh, okay. So what I mean is that we use this negative b over 2a to find the vertex. So in this case, this one is larger than 0. And we know that a is less than 0. Yeah, so yeah. So so you see a heart over the first line. Yeah, this one is like quite hard. You need to understand the ABC thing. Yeah, but I think this one is too hard. It will not be in the test, I guess. Yeah, so just some understanding on this topic. Yeah, so the A you see you can know from the shape, and then the C you can see from the y intercept, and the B actually you can see from the vertex. So in this case, A is negative, right? And then negative times negative you get positive. So if B is negative, then it is wrong. So B needs to be positive. Eh? Yeah, so B is positive. So means that these two are correct. Yeah. Yeah, you are half right. Yeah, but yeah, and then the next one is actually a more like just the first question, like you change the way that you ask. So the first, okay, let's say the first I mean, yeah, on this page, the page 13 is like a bit easier, right? If we ask like this, if it is asked like this, A, B, C, and explain. Yeah, yeah, S- yeah. So for B, B square minus 4. Yeah, so the way to explain C is larger than 0 is just the y-intercept, and then the A is because the the upside down, and then the B to explain that actually the way is on page 12. Okay, so to explain B is larger than 0, we can use the vertex, I guess, is the fastest, the negative B over 2A. Yeah, it's the fastest. Okay, okay, so the next, Yes, yes. Yeah, good idea. Yeah, 2 points. Yeah, yes. So, maximum seconds after it is launched. Yeah, correct. Uh, yeah. So if you look at this tab, right? So if we have this like this graph over here, uh, so you will see that the height of the pumpkin is like it goes until the 133 at the time t equals to 2.75, and then this is where the maximum height is reached. Okay, and then the maximum height is 133. Okay, yeah, so we have this 2 is correct. Okay, okay, the next one, the next. Uh, in your textbook, determine whether the following functions are odd functions or even functions. Or maybe yours this is not in the syllabus. So okay, I explain the even function. So any function that is symmetry at the y-axis, so means that it can be if we reflect it through the y-axis, the the image will like uh yeah, symmetry on the y-axis. It is even, and if it is like uh if to say it is odd, we need it to be symmetry to the through the origin. Uh, okay, even let's see. Okay, so the first one is actually it is odd because if you write the graph out, you will get this line, right? So it is not symmetry through the origin. So an even graph. Okay, so yeah, the And then this one is odd because actually odd is when you have, if you remember, f of x equals to negative f of negative x. Okay, so this one is odd. So it just means that it is like symmetry through the origin. And if we have f of x equals to negative, if equals to f of negative x, then it is even. Uh, f is negative. No, it's not always negative is even, but uh, let's say, yeah. So even is easier to understand. It's like a symmetry through the y-axis, while odd is a symmetry through the origin. So no, because if you see from here, even if the line goes through the origin, it can be even or odd, right? So let's say the line y equals to negative 8x. It is it is odd, right? Because it is symmetry through the origin. So what mean by symmetry through the origin is uh s- let's open this graph negative x. So if you see, or I share this tab. So if you see when x is 2, the value is negative 2, but when x is negative 2, the value is 2. So it is like reflecting through the origin. Yeah, so this one is an odd function because even function is when this one becomes like x squared. So it is like symmetry through the y-axis. Actually, all linear. I mean, some, not all linear functions are odd. For an example, you if you have the function x equals to 0, I mean y equals to 0. Yeah, this one is the a linear function that is even, right? Because it is symmetry through the y-axis. So you need to remember that the even just means you can if you fold the graph through the y-axis, then the image will like uh map on the same part. And odd means that you can verify if it is odd by by using this function formula. I mean using this to check, or you can if you use this to check, or you can see if it is symmetry through the origin. Okay, so the second one is even because if you put in positive x and negative x, the result is the same, right? So this one means that if you plug in positive x value and the negative of the x value, then you get the same value. So h of 1 is the same as h of negative 1. So because of a square thing, so we see that it is even. So same things goes to this. So it is even because when x you put in, the value is the same as negative x, or we say that it is symmetry through the origin. So I mean symmetry through the axis, the y-axis. So the y-axis you can think of it as a mirror, and then the left side you mapped reflect the same image appears on the right side. Okay, so the even is like symmetry, and the odd is like, I'm not sure, is it uh the anti-symmetry or yeah. So the odd function is actually like is symmetry through the origin, but the even is symmetry at the y-axis. And this one it is not even, nor is not even or not, I mean it's also not odd because yeah, on the x, yeah, yes. Okay, so let's use some. Okay, so the next slide, part 3, part 3. uh you need to graph it, to graph it you need, yeah, is it intersect? Yeah, you can graph. To graph it, there are many ways you can solve it. Okay. Yeah, so to compare these two, you see that actually the minus 4 will shift the function to the right by 4 units. Yeah, so I guess what the question asks is that we need to know that minus 4 will actually shift the function by 4 units. So what I mean is that is if you compare x squared with x minus 4 squared, actually the difference is like one is one has the vertex at the origin and one has the vertex as 4. So it's like moving the function by 4 units to the right. Or one other way is that to when x is equal to 0, we are at the y equals to 0. I mean for y equals to 0, the first function we need x equals to 0, and then the second function we need x to equals to 4. So we see that there is an shift of x by 4 units. Okay, and then yeah, this is the manipulation of the function. If you have a 4, if you minus a number, means that you shift the function to the right by the number. And yeah, so this is, I guess, this is what we need to compare. If you minus 3, then the vertex would be at 3, so means that you shift it by only 3, and the 2 will actually like make the function like a bit higher than the green one. Okay, so like yeah. Yeah, yes. Oh, okay. Yeah. Minimum. Yeah, correct. So the domain has the same, but the minimum is over the minimum point is not the same, right? Because one x square has minimum 0 and g x has minimum of 1. and then the range is different, the axis is different, wider stretch. Yeah, so the one half stretches the function, and then plus one translate up one, and then the over one is the negative. Negative one moves the x over to one, and the vertex are different. Yeah. Okay, and then we do page question number 19. Yeah, yeah. I mean, no, you need to graph g of x and then try to graph h of x. Yeah, so if you are tired, then we can like end this one, or if you can still like study another half hour, then we will end on 10:30. Yeah, okay, good, good. Eh? Okay, nice. Eh? Is yeah, because when you minus one, you need to put into the g function instead of just writing the y value. G is the the left hand side of the question. Yeah. So you see that it's like a shift of the function by one unit to the right. Yeah. Or you can try to plot it out and we will see this. Okay, so yeah, so if you want to like construct a table again, or you can just like, yeah, this one. So actually this, the y value is not this one. This one should be x minus 1. Okay, and then we plug in the g of x minus 1. So you see that g of x minus 1 is the same as what you write at the g of... Oh, no, it is not g times x minus 1. It's the bracket means that you plug in x minus 1 to the function. G3 to... Yeah, correct. Mm, let's choose one. Oh, uh, but so you see when the x input is 3, before the y output is g of 3, but now the y output is g of 2. I mean, uh, before is that you plug in x equals to 3, and now you are plugging in x equals to 2. Okay, so the difference is that actually you have shift the function by by 1 unit to the right, so that... Oh, that's not the same, not the same. uh I mean, okay, so first, g of x minus 1 is not x minus 1, right? Is the is g of x minus 1 is this, the function g of x, the function gx given by the question, but we plug in, instead of x, we plug in x minus 1. Okay, so I mean, this one we plug in x minus 1, right? Because if this one is x, then we plug in this one x. So if this one is x minus 1, we plug in x minus 1. Because this is what we do on the functions, right? If g of 2, we plug in x by 2. If x is 3, we plug in x, we replace x by 3. If x is x minus 1, we replace x with x minus 1. No, you need to plot the x value and the y value, right? Because the coordinate depends on x and y value. So g of 2, g of 2 is you plug in y, you plug in 2 to the function, right? So you need to find the value of g of 2 first. Okay, so you know how to find it. It's just plug in 2 is negative 2 2, negative 1, negative 2, negative. G of 2 is 0. Is it? G of. Oh, wait. Wait a negative 2. G of at 2 is 4. G of 2 is 4 for negative 52. Wait, is it? Why so? Yeah, so G of 2 is just plug in 2 to the function of G. So you get 2 plus 2 squared minus 4. Yeah, so yeah, actually, this one the x value is a bit different from what you listed on the left side. Yeah, but never mind. So to find g of 2, actually, you just plug in 2 to this function. So it's not that hard. So g of 0, we know it is negative 16. G of negative 1, we know is negative 7. And g of negative 2, we can see from here is negative 4. Right. While g of 2 and g of 1 actually is not important. We will not need to plot, write them out, is okay. Okay, so from here you can try to plot the graph. Yeah. Uh, wait, no, because g of x minus 1 is also h of x is also a quadratic function, right? And the maximum is also at, the maximum is at x equals to negative 1. To see that is, how about we write out h of x? Okay, h of x is g of x minus 1. So we have x minus 1 plus 2 squared minus 4. So this one equals to x minus 1, x plus 1 squared, negative 3 times x plus 1 squared minus 4. Okay, so you find h of x. Okay, so the vertex is on negative 1, right? So we know that this one is like this. The function is like this, which is let's say the translation. Yeah, we move the function by 1 unit to the right. It's just a translation. Yeah, so from here we plot the red graph. Yeah, I guess the g of x minus 1 is not easy to understand because you need to plug in x equals to minus, I mean, you need to switch x to x minus 1. So you get x plus 1 squared minus 4. And you plot it, you get, what we'll get is this one. So you see that before when x is equal to 0, g of x, you will get negative 16. But now when x is equal to 1, you find h of x to be 16. And when x is equal to negative 2, g of negative 2, the blue one is at negative 4. But when x equals to negative 1, the red one is also at negative 4. So you see negative 2 and negative 1, there is a translation to the right. Uh, so you move the function to the right by 1 unit. So this is what we mean by this negative 1. I mean x minus 1. The minus 1 will, yeah, is just moving the gx function by 1. Yeah. Yeah, so if you see, I share this tab. Okay. Can you see the Desmos graphing app? Yeah, so if you see that your g of x is 2x, while if h of x is g of x minus 1, the red one is over here, but the blue one is like, or or if I say g of x minus 1, it's like you move the function to the right. So if I change the g function like 2 to the x square, you see that it's also moving the red one to the right. Okay, so if I make it more like complicated, you see it's also whatever g of x is, the g of x minus 1 is a translation of the function to the right, and which we can see by, because like to achieve when x is equal to minus 1, the red one is at negative 2. But now when x is equal to 0, g of the blue one, you plug in x equals 0, you get g of negative 1, which is negative 2. So you will see there's a translation. Yeah, and then I guess here is some practice. But if tomorrow is your test, then it is not enough time to do a practice. So we will go into the last section. So I will share the file. So this one, yeah. So if we are given the intercept form, uh, yeah. So you can try to graph the function in this intercept form. Yeah, 4 and 6 are the roots. Yeah, the vertex is uh 5, I guess. Yeah. Yeah, but I guess another way to do is you can just find the axis of symmetry by taking 4 plus 6 over 2, because if you know that the 4 and the 6 will be symmetry at some x-axis, then the x as the line of symmetry will be can be found by taking 4 plus 6 divided by 2, because the line of symmetry is equidistant to 2 points on the same y, on the line y equals to 0. Yes. Yeah, that will be the x value of the axis of symmetry. And then the x intercept you find is 4 and 6. The domain is R, the vertex is 5 and -1. Yeah, so uh you see like this one, because it is a symmetry, the axis of symmetry is like the points will like reflect through this line to get to the other point. So the to find the axis of symmetry, you can take this 4 and 6 and add up to get 2, and divide it by 2 so that you can find the axis of symmetry, because the axis will be equal distance to the 2 points, these 2 points. Yeah, and the range, the domain R1, R minus 1, range larger than equal to 1. Yeah. But actually, if you have the vertex, I mean, if you have the axis of symmetry, then you will not need to construct the table. Yeah, so to let's see. Yeah, so the next page. Yeah. But before you graph it, you can just use the intercept form. So use the zeros to graph the function. Yeah, you need to find the zeros of the function -3, -5. Yeah, so the axis is 4. Yeah. If you plug in the 4 to this line instead of, yeah, but it's okay, you get the same. So get -1. So let me copy paste this. Yeah, so you'll find the vertex to be negative, I mean 4 and -1, and the axis is 4, the x-intercept is 3 and 5, domain and range R and larger than equal to -1. Yeah. Okay, and then the next one. Write a graph that has zeros of write and graph a function that has 0, -4.5, -1.5, and 2. So sounds like you need to use the intercept form to construct the function. Yeah. 2x minus 2. Yeah. Uh, uh, you sh- you leave it like that is okay. Yeah. Y is equal to this one, right? Two. Oh, because this is not a quadratic. So this one is a different question from 34. You will not need to label axis, x intercept with all those. You cannot find. This one just asks us to graph and write the function. So to graph this one, let me demonstrate it. Okay, so to graph this one, let's see. So plug in the This is negative 4.5, negative 1.5, this is 2. And then you see that this function is like, it will be passing through all of these points, right? So just a sketch. Yeah, it will needs to pass through 2, negative 1.5, negative 4.5, negative 4.5. And if x is over this region, you can plug in the x to these three brackets. All of the brackets are positive, right? So you have the line to be larger than 0. But if you go through the x smaller than 2 part, you'll find that this one to be negative. Yeah, so when it is larger than 2, it is positive. When you goes to the left of 2, it becomes negative. And yeah, it becomes positive. And again, if you switch the x to the less than negative 4.5, then it becomes negative again. Because this one will get negative, this one you get negative, this one you get negative. So three negatives you get negative. So, yeah, so actually this you do not need to like multiply them, or is actually does not help. Okay, and then so the next one is like you need to use the zeros to graph the function. So I guess this one is quite same as what we have done on slide number 2. So I guess we will move on to the next one first. So this one, I guess you can do it yourself. It's easy. Yeah, so now it's about the linear exponent and stuff. So from the following data, is it a linear exponent or a quadratic function? So you need to plot the points to see.